Welcome to this movie about the belt sander. Now, I apologize ahead of time for some of the audio quality. There was a lot of echo in the room and the machine is real noisy. But I'll try to summarize the important things that maybe you won't be able to hear in some of the live video. We're going to cover the difference between a belt and a disc sander. Both of these capabilities exist on the sanding machines at the Applied Technology Center. We're of course going to go over safety. It seems like, hey, a sander, no big deal. But there's some things that can happen on a sander that can be extremely dangerous. We'll have a sanding demo to show how you will hold your part and get it supported on the table. And then we'll talk quickly about the cleanup and the vacuum system that exists at the Applied Technology to keep the grinding room very clean. First off, before we see any of the live videos from Don, let's talk about the belt versus the disc sander. First off, Don Howard recommends that engineering students should use only the belt sander and not the disc sander. If your instructor says otherwise, then once again, your instructor trumps everything else. The belt sander is a vertical sander. You just notice that the red arrow, the belt is feeding down toward what's known as the table that I'm pointing to with the white cursor. So that's the machine we're going to want to use. On the side here, you see a hose. That's the vacuum system that'll be sucking a lot of the debris that's coming off of your part so that it doesn't go all over the room and you don't breathe those fine particles. The disc sanders on the side of the sanding machine, I have two arrows here because this is a circular thing. On the right side, the wheel will be moving upward. So if you held your part there, it could be pulled out of your hand and fly upward. On the left side, the wheel is coming down, and if it's not held properly, it could pull the part or your fingers down into this gap. All right, so both of these machines can be extremely dangerous. Probably the most dangerous aspect is the crack here. All right, if you don't hold your part properly, your part might get pulled down into the crack, which would then force your hands against this abrasive surface, which could cause extreme skin damage. This is much worse than just a plain cut, because in a cut, you've got the ability to just suture your skin together. When you get an abrasive injury against a sander like this, it's sanding away the skin completely. And these type of injuries are extremely difficult to heal from. So you have to show this machine the utmost in care. We're going to talk about some safety rules. Let's hear from Don Howard first.
All right, welcome. We're in a sub area of the machine shop. You'll hear a little bit of echoing here today. This is the grinding lab, and this has some extremely dangerous equipment in here, these grinding wheels, and these are not something that a typical engineering 153 student would ever use. So there's two abrasive surfaces. There's a round one and then a flat one. What's the deal?
This is a flat one. This is your belt sanding portion, and this is what you call a disc sanding portion. You have a wheel here. So here again, I want to talk about safety, loose clothing, jewelry, things of that nature, especially clothing. This thing is going to be spinning, and it's like a piece of Velcro as it's spinning. It's just a piece of sandpaper on its face. And what will happen is you get these loose ties or loose clothing, they can get sucked in, and once that sucks in, it's going to suck in your clothes, suck in your body, and you can end up with yourself in trouble. So remember, keep your clothing, loose clothing, and jewelry and stuff tucked in tight. You don't want it loose so that you can get hurt in the machine.
Okay, very good advice from a master craftsman. Don Howard has several decades of experience, both at MCC and in the Eastman Coating Company. All right, so Don, we had some parts. What are we going to do? Some deburring operations?
Yes, I'm going to show you how to do some deburring operations, but a couple of things I want to talk about. We'll talk about the parts. We just mentioned the belt sander. We talked about the disc sander. You have your main power on and off. The only on and off switch you have is here. It's stop is the big red button. Green is the start button. All right, you have your table here, it's to rest your part against. You have your table here, you can rest your part against. You can also tip, you won't be tipping your parts, all right? You're not grinding, you're not precision grinding or belt grinding, anything on these, you're just coming up to use them to deburr. One of the things I want to make you aware is there's a gap between these tables, all right? You want to be very careful of that gap. That gap could be detrimental to you.
So that could try to pull something, you or your finger down in there, it could be very dangerous.
That is correct. It's a pinch point. A lot of students like to come up and if I'm standing here like this, you see I have the thin part again. This thin part has the ability to get pulled in. So if this disc is rotating in this manner, right, and I'm coming up here to belt sand this, it can get sucked in. If it gets sucked in, where's my thumb? So my thumb gets here, this continues to get pulled in like a wedge, and now my thumb is in a pinch point, and I'm losing flesh. Now, the thing is, it's not like a cut, this is abrasive, the material is gone. It's in fine, very fine powder puff, gone, okay? So you want to be careful, extremely careful when you're here. You do not want to machine your part like this here. You're about standing, stand up, use the table, let the table do the holding, right? The force is downward, so you always want to use this so that the wheel is pulling downward. This side, the wheel is spinning this way, so it will lift your part up. You don't want to launch your part, so you want to work here, all right? Work like this, and allow it to pull down to the table, right? Set the part down, allow it to pull down to the table. Got to pull down to the table. Don't stand up here, because now look where my hand naturally wants to be when I hold my part here. It slams it down, and now if I have burrs or anything, I'm going to cut my hands, all right? So use the table to support your work, all right? Extremely careful. This is another bad practice. I'm just standing like this to show you how to use the machine. But I typically wouldn't stand here like this with my bare knuckles facing this machine. I would not wear cotton gloves over here, all right? Because here again, it's like Velcro. There are opportunities for gloves to get pulled in. I would normally stand out in front of my machine, and I would stand out here and work with my cart here, and my hands are out here away from that wheel, all right? I do not want my hands near that disc. I like my hands. I want to go home with my hands and my fingers, all right? And the flesh that's on the back sides, all right?
That would be a nasty injury to have all the skin sanded off your hand. I can't even imagine how long that would be to heal.
I can't imagine.
You might even need a skin graft. You might even need a skin
Jason,
graft.
you had any comments on that?
Yeah, it takes several months for it to come.
Several months. Okay.
Several months, and talking from a man with authority.
Okay. All right, so you want to be always, your part, if I'm learning correctly, Don, your part should always be resting on the table. It's called the table.
Right.
All right. Now we're coming over to this. Now is this belt going to be in the downward direction?
It's always going to be in the downward direction. The only one you'll have to really pay attention to what side you're on is the disc. Your belt sander is always going to be turning down towards your table. All right. Same scenario. I don't want to just lay this like this and try to grind it because it can grab and bind up like this, and then I'm in trouble again. Just hold it up like this. Stand off to the side. It's natural for me to stand to one side or the other, and then I can sand my part. Boom, boom, boom. All right.
So you said don't put it like this, but if you're doing a corner, you can just bring the corner because that's not going to get sucked in like that.
Right, I got very little surface area there. Here, I got it like this, part can get pulled up and go in between that crab. All right. Where here, I got a lot of surface area here. I got hardly anything here, and it still stands a chance if you're not careful. But I'm just lightly doing that edge. All right. So here, safe. Here, safe. Okay.
So Don, I think what I'm hearing you say is you should try to position your hand so that if you slipped or dropped the part or something, your hand's not going into the bracelet.
That's correct. You do not want your hand anywhere near that wheel.
Now, I see a lot of wear on this out here on this side. Does that mean someone probably held their part on the right?
That's a good possibility. Some people like to work in the front. Depends on the individual. I'm just trying to teach you guys a safe practice.
Is there any speed adjustment that students need to be aware of here, or is it this
No.
just set by the instructor?
It's an automatic. It's on by the belts and the pulleys that are already there.
Okay, so there's not any adjustment we need. Do we need to adjust the tables in or out? Is there a certain amount of gap we should see on it?
These are already fixed. These are a fixed table. You can't change it.
Let's review the safety rules that Don went over. No loose closing. This goes for all machines at the Applied Technology Center. But once again, especially here on a machine that can be pulling you down into that crack, pull you in and get very bad abrasive injuries. No jewelry to be caught in there. Long hair, once again, is a no-no. It needs to be tied back or put back into a hat or some kind of constraining device. You need to support your work on the table. Okay, and Don showed the proper ways to do that, and we're going to review it again later on. But you're never to just hold a part up against the sander. It needs to be supported by the table, and you don't want to put the flat side of the part down where it could get pulled and sucked into that crack. But we will review that because that's the most important thing when we're sanding. And also Don talked about positioning your hands away from the belt. You always have to be thinking that, hey, if this part slips out of my hand or something happens unexpectedly, where are my hands going to go? And if the answer is my hands are going to go right toward the belt, then you need to reposition your hands. So Don said we're standing in front of the machine, we're holding our hands off to the side, so that if something falls out of your hands are not going into the belt. Also, there is the on-off button. The red button is the emergency e-stop. It works a little different in that it does not stop the belt completely because there's so much momentum in this belt. Once you press that the e-stop, it'll stop the power, but it usually takes somewhere between 10 and 20 seconds for the belt to come to a complete stop. So if you're getting into trouble with this machine, if let's say you're holding the part in the wrong way, it gets sucked in the crack, and now your hand gets wedged up against the belt, even when someone presses this red button, you've still got at least 10 seconds of wear and tear going against your skin. So keep that in mind. We're going to move to a sanding demo next with Don.
So there we go. Don, are we actually ready to do something? Good. Now, how does one decide whether they're going to use the round wheel which spins or that flat one which is linear?
I guess it depends on the work and what you're comfortable with. I personally like the belt sander, and the other thing is maybe I have a clearance issue. You notice that this guard is not right here, so maybe I got to get in close to an edge or something where I can't, I need to have this edge out here. So it depends on the type of work you're doing for the most part.
Well, let's say that you're a novice student entering 153 doing basic deburring, which is probably what you're doing. So we're going to use the vertical surface.
Stick with the vertical.
Okay. All right. Are you going to demonstrate just the vertical then first?
Yes.
Okay. So we're going to just use the vertical. And we're going to deburr some parts. Can you also put like a chamfer on something?
Yes.
Okay. I don't know if you want to show us that, but the answer was yes. We'll see. All right, it's really noisy. In trouble and someone hits the e-stop, you still got a ways to suffer. All right, Don, while you were pushing that in there, you're not pressing it in real hard. You're just like letting the
sandpaper do its work.
Do its work. And so now the sides don't have those sharp surfaces, and this process is called deburring.
Deburring, right?
Now I'm looking at this belt over here, Don, and I see a little rip in it there. Is that okay?
No, that's not okay.
Okay. So if a student saw something like that, they should report it immediately to the instructor.
Yeah, that's correct.
Okay. Now, Don is experienced that he's going to work around that area today.
Yes, now that we notice that there's a rip in it, what'll happen is if you've got a rip in there, that rip can get worse. But what if I got my part here, it would grab a hold of this, and now I rip more. Now I have a piece of string. Think about this piece of string, because this is a fiber belt. The belt rips and tears, and now it comes down, and now that can act as a knife that's cut me like a weapon.
All right. Now, what are we going to do next? Are we going to do the circular?
All right.
I think that would probably give us enough experience today.
Yes. This is kind of a short piece. Wasn't too brilliant on my part to give it so short, but I'm going to show you how
Okay,
to do it.
now it's short, there's no thing to hold it in, you just have to be more careful.
Correct.
All right. So Don's going to put the machine on, it's going to be noisy.
Again, off to the side.
Off to the side, turning it, just lightly pressing it against the tailgate. I can see the curve that's moving, getting to pull off. Taking off the sharp edge. It's almost like a little chamfer there.
Right. Just take the bird off. Very careful. Short, so it's hard to hold, so I have to be very careful. You notice I let the table do the work. I just held it and guided, and then I swung the bird out into the blade.
All right, so it's over 10 seconds to bring this thing to a stop. Well, it's probably more like 20 seconds. All right, so Don has demonstrated that. Once again, after the machine is off, you wipe the machine down, clean up any chips on the floor, make it nice and tidy. It's very important for this room to be super spotless because the machining students are doing highly precise work in here. Don, anything else we need to know?
No.
Now, I see a tube coming out of the machine. Does this require air of some kind?
It's actually a vacuum system, so when you come in the room, you'll turn on the vacuum. That's why it's kind of hard to hear in here. So you'll come in, there's a green button on the side, you'll push that button, and it'll activate the vacuum.
Would a student normally have the vacuum on when they're working in here?
Yes.
Okay. We didn't have it on today because it's pretty noisy. So your instructor is probably going to instruct you that before you start working, you would hit the start button, and we can hear the sucking sound, okay? And that would help evacuate some of the dust and chips.
That's correct.
Does that go into some filters that just go out in the
The other filters when it goes up and out, and then there's the filter system on top.
All right, so you'll be using that. So last thing you do after you clean off the machine, and you're the last one out of the room, you're going to hit the stop on the vacuum system. Hey, we appreciate you listening again, and thanks again to our producer, Jason Eman, Don Howard. So sayonara, everybody. This is John Wag signing out from ATC.
Let's review the important points on the sanding demo. So I made a little diagram here. We've got the belt of the belt sander, the table, and the part. And I wish I could get a little fill, but my CAD software didn't allow me to fill here. But think of this as not just a picture frame, but think of it as completely filled with material. All right, something's wrong with this setup right here. Do you know what it is? Well, I'm going to tell you. You never lie the part flat like this on the table. Don said if you put it flat with a lot of surface area up against the belt, you can get into a situation where this part would get pulled up against the belt and get sucked, and this front edge would get sucked down into the crack. So this is not something that you're ever going to want to do. The only possible exception is if you were just going to be presenting a corner of the part to get maybe rounded off, and you turn this a little bit so that only the corner was touching the belt, that would be acceptable. But you're never to put the whole side up against there because that could cause the rotation and get sucked in. All right, let's go to the next one, and let's look at this diagram. Tell me, what's wrong with having the part here? Well, if you said never hold the part above the table without it being supported by the table, you're absolutely right. So remember, you're not to just freehand up there. It's too easy for you to maybe lose grip or balance or something and have your hands go into this belt. If this belt is capable of taking steel away from steel, it's certainly very capable of taking skin away from bone. Lastly, how about this one? Is there anything wrong? No. Well, it says yes here. It says yes because this is the way that you should support your part. You want to have the long edge, the edge of your part, up onto the table. Okay? This way, it's virtually impossible for this part to get pulled down into the crack. Also, you're holding it at an angle, and your hands should be out to the left side of the belt. Okay, so if you're putting some pressure in to put this against the belt, and Don mentioned that you should only put a very slight amount of force there. If your hand slipped, you want your hands to go to be wide left of this belt. All right, so keep in mind, where are my hands? Where will my hands go if this part slips out of my hands? And the answer should be your hand should be to the left of the part. All right, so we got a whole long edge supported there. Nothing's going to get sucked into the crack, and this is the proper way to have a part supported for belt sanding. We also talked a little bit about cleanup and vacuum. Because of the vacuum system, there's not a lot of cleanup, but there might be some. So first thing is, when you go into the grinding room, you need to turn on the vacuum system. This will allow the system to suck out most of the debris that's being sanded off your part. This has the benefit in two ways. Number one, it keeps the room clean. It has less for you to have to clean up. And two, it keeps the fine particulates that are being generated from being airborne and potentially breathed into your lungs and so forth. Okay, so after you've turned on the vacuum system, then you're going to perform your sanding. You're going to turn off the machine, obviously, wipe down the table, do any sweeping that's needed. There we go, sweep the floor. And then last thing, when you're leaving the room, you want to turn off the vacuum system. Let's look at some questions for you to answer to prove to your lab instructor that you indeed know how to use the sander safely. First question, list the 5 safety rules that we listed toward the beginning of this movie for using the belt sander. Number 2, approximately how long does it take the belt sander to stop after the E-stop is pressed? 3 says, why should a part not be placed flat on the table of the belt sander? 4, why should a part never be sanded without being supported on the table? 5, why can a belt sander potentially cause more skin damage than a cut from a sharp tool? Thanks for listening to all our videos. This is the last one in our video series at the Applied Technology Center. Perhaps in the future we'll get our team together and make some more videos. I hope these helped you work with the machines in a safe way and to your advantage.